Assalamualaikum and hello. We are from Group 2 Subgroup 4 will present our journal review with the title of Process Optimization of Biogas Energy Production from Cow Dung with Alkali Pre-treated Coffee Pulp. There are 4 sections in this presentation. The first section is the introduction, objective, and methodology will be explained by Amalina. The second section is a discussion, results, and conclusion will be explained by Aini. The third section is benefits from this journal will be explained by Elina, and the last section is the suggestion to be made from this journal will be explained by Akmalina.
Coffee is the second largest traded commodity in the world and generates large amount of byproducts and residues during processing. Coffee pulp waste and byproducts produced during coffee berry processing contribute a source of severe contamination and pose serious environmental problems. Therefore, disposal of coffee pulp waste has become an emerging environmental problem worldwide. Cow dung contains a considerable amount of metagenic bacteria with low amounts of cellulose, lignocellulose, lignin, and other organic components which are essential for bacterial growth and for biogas production. On the other hand, although coffee pulp contains cellulose, hemicellulose, and proteins in large amounts, it lacks a considerable bacterial population to degrade the toxic components to produce biogas. This fact suggests that the researchers to employ a mixture of coffee pulp and cow dung that would hopefully result in a synergistic effect towards high biogas production. Hence, the main objective of the present study is to comprehensively analyze the use of coffee pulp and cow dung additives in the right ratio to increase the aerobic stability towards biogas production.
Next is materials and method.
For the materials and methods, the first step is the collection and preparation of substrates, where the coffee pulp waste was collected from the coffee processing industry and the cow dung inoculum was collected from a dairy farm. Next is the pre-treatment and characterization of coffee pulp waste, where the coffee pulp was grounded in blender, treated with alkali, washed with distilled water, and then neutralized to a natural pH. The next step is the anaerobic digestion assembly, followed by the optimization of biogas production, the quantification of biogas by water displacement method, where the total biogas production was measured by water displacement method, the chemical analysis of substrates, and then lastly is the analysis of biogas, where the methane content in the biogas was measured with gas chromatograph.
Now, we move on to the discussion part. I'm going to highlight the key findings in this study. First, the effect of alkali pre-treatment coffee pulp. Many previous studies reported that alkali pre-treatment increased biodegradability and resulted in more yield. However, the choice of pre-treatment method highly depends on the type of lignocellulose waste. Nevertheless, it was proven in this study that alkali pre-treatment method gave a positive effect on coffee pulp waste by raising the density of carbohydrates and protein. As we can see on the table, the density of carbohydrates and protein in coffee pulp increases after alkali pre-treatment. It was discovered that 1:3 ratio of coffee pulp to cow dung yielded the highest biogas production, which is 144 ml per kilogram, after 96 hours of digestion at 40 degrees Celsius and at a pH of 8. This result suggested that coffee pulp alone produced 92% more potential in biogas production than conventional cow dung. Cow dung provided the methanogenic bacteria, while coffee pulp supplied the organic components such as cellulose, hemicellulose, and proteins. The proper ratio of coffee pulp to cow dung, which is 1:3, resulted the most synergistic effect for biogas production. In summary, coffee pulp, when mixed with an optimal proportion of cow dung, was discovered to be a promising substrate for biogas generation by anaerobic digestion. The study also concluded that the co-digestion of coffee pulp and cow dung at the ratio of 1:3 yielded the maximum biogas after 96 hours. Other parameters to operate this co-digestion at this ratio are the temperature of 40 degrees Celsius and the pH of 8.
Now, I am going to share the benefits of this study. First, The outcome of this study has supported the fact that the conventional combustion technology has to be upgraded to prevent hazardous emission into the atmosphere. Besides, the alkali pretreatment method has been reported to be able to enhance the biodegradability and the yield of energy. Most importantly, coffee pulp waste that previously contributes to severe contamination and serious environmental problem worldwide can now be utilized and optimized to produce energy, especially when employed together with cow dung.
To further optimize the use of cow dung to produce biogas energy production, there are several factors to take into considerations. First would be to improve the degradation of the cow dung. Cow dung is rich in lignocellulose, which is linked to the production of biogas. The surface area matter for enzymatic saccharifcation of lignocellulosic materials. Liu and Zhu 2013 also stressed the importance of removing hemicelluloses before lignin to obtain an efficient cellulase activity and enhance the enzymatic saccarification. Another phenomenon that might prevent an efficient saccarification of lignocelluloses is the unspecific binding of the cellulase to lignin and hemicelluloses. Sulfonation of lignin has been proven to have a positive effect as it hinders the binding of cellulase to lignin. Second, many solid materials need some kind of grinding and dilution before it can be proceeded into anaerobic digestion. For lignocellulosic materials, the pretreatment should ideally produce only low amounts of degradation products from lignin and hemicelluloses, as this might inhibit the hydrolysis and further degradation. For example, of physical pretreatments, such as slice centrifugation can also be applied on sludge and has been shown to increase biogas yields for 15 to 25%, and it is suitable to be used in full-scale bioplants. Furthermore, sludge can be treated with high pressures such as liquid shearing, collision plates, and high-pressure homogenizers, leading to mechanical disruption of cells. The treatments increase the biogas yields, and at the same time, the hydraulic retention times of the processes could be reduced. Meanwhile, physiochemical pretreatments such as steaming and steam explosion can degrade the hemicelluloses and can change the lignin structure. Steaming and steam explosion is one of the most investigated and applied pretreatment methods for treating lignocellulosic materials. Therefore, these are the suggestions to improve the biogas energy production from cow dung.
This is the list of references for our presentation slide 2. So that's all from us. Thank you.